Please welcome M. Charity to the stage next. They are a PhD student at NYU Tandon with an interest in collaborative AI. They make robots, they make games, they make robots that play games, and robots that make games. So, without further ado, let us welcome M to the stage.
Hi, my name is M. Charity. My pronouns are they, them, and I'm a PhD student from the Game Innovation Lab at NYU Tandon. Today, I'll be talking about procedural content generation systems, particularly applied to games, and how we can make cooler, more interactive systems that adapt based on real-time player input. To start off, for those not familiar, procedural content generation is a method that refers to creating artifacts algorithmically instead of manually through human labor. And in games, this can be anything from generating levels, weapons, enemies, random encounters, even terrain and environmental objects like trees. And this technique goes all the way back to the 80s, seen in games like Rogue and NetHack, and then grew more in the 2000s with simulation games like the Civ series. And it really exploded around the 2010s with games like Spelunky, Fast and Light, and Hades. So PCG is all fun and cool and convenient for making never before seen content relatively quickly, but there exists a lot of drawbacks. First, we have what is referred to as the 10,000 bowls of oatmeal. And this is where the system can make thousands of samples of content, but most of them honestly end up being the same, very little variation. So that's something that No Man's Skies worlds and the weapons of Borderlands 2 suffered from. There's also the problem of broken generations, or the system behaving in unexpected ways that could potentially break the game. And artifacts could overlap with each other if not explicitly separated based on the type of content that is produced. And lastly, some PCG systems can create content that is both unique and playable, but it may look awful and artificially made. This is something that is especially prevalent in the games and AI communities. So we can try to solve these problems by adding some human interaction into this automation process for content generation. And today I'll be showing 3 of my own projects that look to alleviate the challenges of PCG systems. The first being my research project, Baba is Y'all. Second being my Pico 8 micro game called Wizard Sakabon. And then finally, I'll finish with my Twitter bot, the Aesthetic Bot. So first, Baba's You is a indie game that came out in 2017 as a jam game and then was later developed into a full game in 2019 by Hempoli. And it's a lot like Sakabon in that the player has to push sprites around in a certain way and position in order to solve the level. But the catch is that some of the blocks affect the rules of interaction for the level. So in the GIF on the left, you can see that the block's wall is stop is preventing the player, Baba, from continuing. And only after moving one of the word's positions away from the group can the player move through the wall. And it's a tile-based game with lots of overlapping mechanics and systems at work, and it makes for a great test domain for solving and generating levels. So this game was used as a test bed for our online level editor called Baba is Y'all. And this is where people can create their own Baba is You levels, test them, and then submit them to the website for others to play. You can even rate the levels that are submitted or modify levels that were previously submitted to make it even better. And what makes this system different from other level editors is the PCG collaboration system underneath that tries to help the user develop a particular level. So both the AI and the human user are developing a level together. And this PCG system will try to evolve the level, make it different from other levels already in the website. So for example, adding a new rule that hasn't been used as often or in combination with other rules. And by generating these new levels, the user can start from and edit themselves. It's a back and forth conversation between the AI and the user, and both parties have full control over how to edit the level itself. And of course, the level can be evaluated by either the human or solving agent to test for playability. So coming off of the theme of Sakabon and solvability, we have another domain where only the AI backend is generating the levels. But how do we determine which levels are solvable and which levels are unsolvable? And again, the AI can try to solve it itself, but maybe it can only solve it up to a certain point. So what if there's a level that is too hard for an agent to solve, but a human can solve it if given an infinite time? So Wizard Sakabon is a system that gamifies the solving process by making it a competition between the AI and the player. So the solver agent, or the wizard, will challenge the player to try to solve the level and determine whether it is truly unsolvable or if the agent just needs to search it and give it a little bit more time and search a little bit harder to find a playable solution. So let's see. Oops. And while not implemented in the system, we could develop an agent that searches like a human and is able to solve levels faster and find whether a level is truly unsolvable or not, and it would save a lot of time in the generation process for future PCG systems. So lastly, we try to address the problem of procedurally generated content not looking like they were made by humans. But how exactly do you determine something to look human? Well, you need lots of human evaluations, but people get tired of answering questions all day. So what do? Why not integrate the question directly into something they look at all day, like Twitter? And now you can get some really interesting looking levels using the feedback you found from Twitter users. So with this system, a human designs their own map using a super small tile set and super small canvas area. And there's no playability involved. It is purely based on how the map looks and how aesthetically pleasing it is. And then a PCG system will make its own map and evaluate it based on what it thinks humans will like the most. So these two maps will be pitted against each other in a Twitter poll. And the user will be asked which map they like better. And at the end of the poll, this map is returned back to the system so it can make even better maps. The PCG system will learn the aesthetically pleasing maps and try to emulate the visual patterns that are found in the maps that were voted the higher. And it updates its network trying to make these better looking levels. So after a few pollings and a few more user submissions, we start to see like different types of aesthetic emerge and different tile patterns, some of which the PCG system will try to emulate in its own generations in order to make better levels in the future. So there's so much work that can be done in games that involve PCG, and I believe that this will make games more engaging for players while maintaining the quality of the content generated. So I have a brief wish list of future features that I want to see in games that could incorporate, for example, recommendation systems, ways for the AI to adapt to a player's playstyle, actually helpful companion agents that could help the player play or design a level. You could have levels that have different types of patterns and content as time goes on. And we can have content that focus solely on the aesthetics of the level or whatever sample is trying to create. And actually some of this work has been done already in the academic community. So particularly the PCG workshop that happens every year, and it's about to happen this September. So please go check out the amazing work that has been done by the researchers there. And you can find a lot of inspiration for PCG systems that you can incorporate in your own game. So finally, I have some links to the systems that I mentioned in the talk. The middle column is for the academics in the audience and those interested in reading 8 to 12 papers about, or 8 to 12 page papers about how the systems work. And the right column is just for those who want to play around with the systems and get your own impression about what I talked about before. So thanks so much for listening to my talk, and I hope you are inspired to make some cool PCG systems in your own games or projects.
Thank you, Em, for that super dope talk. Let's show Em some hype in the chat. In the meantime, please, if you haven't already, check out the Game Devs of Color Expo job board. There should be some super cool job opportunities by listings from companies like Xbox, aka Microsoft, and other big names in gaming. Take a peek.